Hello and welcome back to Nunley Math. I appreciate you joining us here today as we are working our way through the 7 different types of functions that I expect my students to be familiar with in my Algebra 1 class. We've talked about 5 of those already, and we're splitting these up over a series of 7 different videos. Remember, our goal is not to exhaustively understand everything about these functions at this point. Rather, our goal is to develop a familiarity with functions in general and the different function shapes or families that can exist. So, today we are looking at functions that look like this. F of x equals 1 over x. Notice that the x is in the denominator of a fraction this time. That's the reason we call this a rational function. A rational function. Remember, rational numbers are numbers that can be written as fractions. Because this x is in the denominator of a fraction, we call this a rational function. It's in the denominator of a fraction. And just like before, I'm going to make up some domains. I'm going to plug them in and see what I get to come out. Remember, the goal of our relation, or this function, is to take x's and map them to f of x's or y's. So, for example, if I were to stick in a 1, f of 1 is 1 over 1, which is 1, giving me the coordinate 1, 1, which I then plot on a coordinate plane. If I stick in a 2, f of 2 is 1/2, so I get 2, 1/2. If I put in a 3, f of 3 is 1 over 3, or 1/3. At this point, I'm starting to pick up on something. If I were to extend this to 4, I would get 1 over 4, which is 1/4. If I were to stick in a 5, I'd get 1/5. If I were to stick in a 6, I'd get 1/6. If I were to stick in a 7, I'd get 1/7, 1/8, so on and so forth. No matter what number I put in, this is continually becoming a smaller and smaller fraction. Notice 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, 1/10. No matter how far I go, this is going to be a smaller and smaller fraction that will never actually reach 0. If I were to put 1,000,000 in for x, I would get the fraction or the result or the range value of 1 over 1,000,000. Because of that, I draw a line that goes out this way but does not touch the x-axis, or the x-axis, because it will never have a value of 0. Let's look at the other direction. If I were to put in a -1, f of -1 is 1 over -1, which is -1. If I put in a -2, f of -2 is 1 over -2, which is -1/2. And at this point, I start to recognize something else. This pattern that I saw with the positive numbers seems to be repeated with the negative numbers. I put in a -1, I get a -1. I put in a 2, I get a -1/2. I put in a -3, I get -1/3. Then -4th, -5th, -6th, -7th, and so on and so forth. There's no way this ever becomes a 0. Now, because of that, I'm going to draw a dotted line through here. You can see it's in blue. I don't know if that comes through very well on the camera or not. I'm drawing a straight dotted line through the middle. And this dotted line has a special name. The value of x, sorry, I'm going to back up to say I got ahead of myself for a second. I've drawn this dotted line, and what we're saying is no matter the value of x, we will never get a 0 to come out. This line, the horizontal line, is on the x-axis. The equation of that line is y equals 0. I give it a special name. It's called an asymptote. Notice I pronounce the P. Usually we don't say the P. This is an asymptote. Asymptote. An asymptote is a line that your graph forever will approach, but will never actually reach. That's what's going on here. Over here, it's also approaching from underneath, but it's never actually going to reach. No matter how far on and on forever my graph goes. Now, you'll notice I've not connected these lines. I want to talk a little bit about what goes on in here, because some interesting things happen in here. If I were to pick 0 for my x, Do you know what f of 0 would be? Well, any number divided by 0 is undefined. You're not allowed to divide by 0. In fact, the value of x cannot be 0 because you cannot divide by 0 ever. That's one of the big no-nos in math. And I want you to put a little notation to yourself here, because that's going to be very, very important in terms of making rational functions easier to work with in the future. Since there is no way I can make x a 0, I'm also going to draw a vertical asymptote right here. Remember, an asymptote says your graph will never touch this line. This is x equals 0. Vertical lines are always x equals. And then we're going to figure out what goes on in this space. Now you'll notice I'm out of room in my table. Please keep in mind those tables are purely arbitrary. I put that many rows in them because that's how many fit nicely, but I could have just as easily added more rows or left some out. Sometimes we'll fill them all up, sometimes we'll need extra. I'm going to go over here to the side and give myself a little bit of extra room. And we're going to see if we can find any other values. In between 0 and 1, I don't know what's happening, so I'm going to pick an x value that's in that space. F of 1/2 equals 1 divided by 1/2. Any idea what that is? Please keep in mind that division is the same as multiplying by the reciprocal. So I can think of this instead of divided by 1/2 as being times the reciprocal of that, which is 2 over 1, or 2. This is the coordinate 1/2, 2. If I put in a 1/3, I get 1 over 1/3, which is the same as 1 times the reciprocal, which is 3. And I get 3. Notice what's happening here. My value keeps getting bigger and bigger. A 1/2 gave me a 2. A 1/3 gave me a 3. A 1/4 would give me a 4, and so on. Your graph, I'm going to switch back to green, your graph continually approaches this line without ever crossing it. If I were to do this with negatives, which I won't for the sake of time, you're going to find that the same thing happens on the other side of your graph. This is the basic shape of every rational function. Every rational function will have a vertical asymptote and a horizontal asymptote, and they'll make these two curves that look kind of like this. Now, sometimes the curves will be in different quadrants. Sometimes they'll be farther from this center. Sometimes they'll be steeper, less steep. There's a lot of different things that can happen with those curves, but it will always, always, always make a curved shape. Let's talk about the domain. The domain says, where does your graph go from left to right? Notice that this graph curves down and goes forever to the right, and the graph curves up and goes forever to the left. So x is any x as long as it goes where my line goes, forever to the right, forever to the left. The only place my line doesn't go, or my graph doesn't go, is right here at this vertical asymptote. My x will never be a 2. So I'm going to put all x's as long as x is not a 2. For my range, notice my range is going to be f of x, or my output. Every value of y is going to work as long as it goes the same places that my graph goes up and down. Notice my graph starts here and goes up forever, and it starts here and goes down forever. It's going to go forever in both directions. If I come back toward the middle, though, you'll notice that it comes down and then it shoots out. It does not connect because y can never be a 0. That's what this asymptote says. So my y, or f of x, is anything as long as it is not a 0. Couple other things you might want to recognize as we look at this. This does have a diagonal line of symmetry. Has a diagonal symmetry. It actually has a second diagonal symmetry coming the other way as well. And it also has rotational symmetry. If I were to spin this, This graph up here would rotate down to this side. This graph would rotate up to this side, and they would match. Anything else you notice there that might be of use or interest? Let's see. It does not have a vertex. It does not have a vertex. The pattern continues doing what it's doing, but there is a really significant point right here in the middle where your asymptotes cross. I think that's going to be sufficient for today. We have one more of these types of functions I want to talk about. After we discuss that last type of function, we will go back and look at all of these together and try to tie them together to make the process of graphing these just a little bit simpler. As always, thank you for watching. Make sure you leave a comment in the comment section if this has been helpful to you. Please take the time to like and subscribe so that you receive an update. Make sure you turn on your notifications, and hopefully what we're doing here will be useful to you. Thank you so much for viewing. Best of luck to all of you guys. Take care.